Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video and also subscribe to our channel. Help us to share and subscribe to our channel. In this platform, we have over 180 videos, and there are different topics that you can lay your hand upon and you can learn without no problem. You surely learn it. And this problem, we are still working on complex analysis. It's a very wide topic course in mathematics. We have done a lot of things on complex analysis. At this moment, we are improving of analytic part and principal part, which you can see. You see it by the end of the video. You understand how to prove it, how to get analytic part and principal part. Please help us to share our videos and subscribe to our channel if you have not before. And if you want to make any donation at this present moment, we need a bigger board, we need a bigger board, and we need better camera. As I'm talking to you, we are still on our normal phone, normal small camera of doing this thing. You can make your donation. You can call us on this number 234 8034495 990. You can make your donation on this. You can call or you WhatsApp call or you WhatsApp calls. And WhatsApp calls. Also Telegram is allowed. Telegram also anyhow is allowed. Please make us just contribute. No more amount is small at this moment. We need a better camera, and so that at this moment we have over 180 topics available for you to work on. To learn. It means you can come to our platform and you can view and go and write any exam without any problem. Okay, now back to the real business of the day, which I have proving of analytic part and this part. Now, if I have for instance, we all know that my f of z at z naught r, which is a real number, which z minus z naught, it will be less than what? R, which is a negative part. I think I've shown that now when I was talking about Maclaurin series, that I have a circle like this, I have something like this is a minus, and so on and so forth. And check on our Maclaurin series. We have done that before when I was explaining Maclaurin and series. Now, when I have it this way, now oriented circle, radius of CL. Now, it means my absolute value of Z naught less than P less than R. Now, it means my absolute of R equals to R, which is an absolute of 1. Now, it means my 1 all over minus Z can be equals to 1 divided by C minus Z naught plus Z naught minus Z, which I can say that 1 divided by x minus Z naught and Z minus Z naught. Please take me for that. What am I manipulating now? This is equals to this is equals to this, which is normal. Now, yes, it's normal. Now, it means I can say that this can be also 1 divided by x minus Z naught and 1 minus Z naught divided by x minus Z naught. Now, if I have something like this, what am I trying to do is that I think we have something like this. We have something like this. Please, you can make it. Okay, now I can now continue my work. How will I go from here? What am I trying to I'm just working on this particular area. I'm manipulating. As a mathematician, you must learn to manipulate. You know, this minus this, surely back to where I'm coming from. When I use my factorization in mathematics, which is your GSS, primary school mathematics, you can do something like this. When you expand, you have now anything you are doing in mathematics, once you are moving forward, you must be able to move back. All this, I'm just trying to come from my limits, which is my limit. Now, since I have this form, I can say that what can I do here? Okay, I can say that 1 all over x minus z naught bracket dot bracket of 1 minus z naught divided by x minus z naught and all brackets of minus 1. Now, with what I'm having here, now I'm having what is called binomial expansion, which we have done that when I was explaining Maclaurin. I've explained that at the point of Maclaurin, when I was explaining Maclaurin, that a degree of minus, when you have a degree of minus, with that, it's always infinity. It's always infinite. Now, finite, it's always infinite. I mean, finite. It means I can say that 1 all divided by x minus z naught. Now, x minus z naught, I have a bracket of 1 and plus z minus z naught all over x minus x naught plus I have z minus z naught divided by x minus z naught. Now, this one will be square plus and so on and so forth. I don't have time to be moving and moving and moving. Now, it means what am I working on? I'm working on my expansion, binomial expansion, which is of degree of minus. This degree of what? Of minus. I've showed that in our previous video, which is under Maclaurin series. Now, I cannot continue by having, I will have 1 all over what? Z minus what? Z naught, x minus z naught of this, of, let me use j equals to 0 to infinity. Now, I want to just generate a form of what it means. This is when my is raised to power 0, powering is 1, multiplying 2. It means I can generate of this of z minus z naught divided by x minus x naught, z naught, all bracket of when my I of my g. Now, it means when is at 0, it will be 1. When at is 1, it will be at 2, and so on and so forth. That is n time generation. Now, since I have it this way, when I have it this way, I cannot continue by saying that we are talking about now we are talking about f of z. Now my f of z divided by x minus z can now be equals to summation of I. Now this is infinity, something I've taken place, I've taken a 1, it means j equals to 1, j equals to 1, I have z minus z naught divided by x minus z naught, all bracket of, now this upper one, there is something between upper and lower. This one will be j plus 1, why this one will be j? Will be j. Now, okay, j. Okay, yes, will be j, will be j. Which I can also say that now let me first, before I generate my this, I can say this of z. Now, of z. Okay. Oh yes. Okay, am I doing the right thing? Okay, I'm just talking to something for those that are still in learner. Let me just rub this part now. I'm not doing the right thing there. Now, park bracket of J. Now, provided, let me make condition my Z minus Z naught all over X minus Z naught absolute value less than 1. Less than 1. Yes. Provided if that is less than 1. If that is the case, it means I'll be having 1 all over Z minus Z naught and now 1 minus Z naught. It means bracket of this from infinity to J of 1, from infinity to J of 1, it means I'll be having Z minus Z naught bracket of J divided by Z minus Z naught bracket of this is bracket of J plus 1. J plus 1. Now, since I have it that way, it means my f of z divided by x minus z will be equals to, now, summation of z, j equals to 0 of infinity, and f of x divided by x minus z naught bracket of j plus 1 dot z minus z naught bracket of j. Z minus z naught bracket of j. Now, I cannot continue. Okay, with what I'm having here, I cannot say that, okay, f of z. Now, I cannot say that integrate to both sides. If I integrate the f of z, the z divided by x minus z, it will be equals to summation run from j of 0 to infinity and integral of f of x divided by x minus z naught bracket of x plus 1 dx and z minus z naught bracket of j. Now, since I have it this way, it means I'll be having 1 all by 2 pi integral of f of z bracket of x minus z x minus z dz dx. Okay, the x, now the x will be equals to limit of this of j to 0 to infinity. I'll be having 1 all over 2 pi of I integral of f of x bracket of x minus z naught bracket of j plus 1 and the x z minus z naught bracket of g. Z minus z naught. Now, f of z will be equals to summation of j equals 0 to infinity c of I bracket of, because everything here that is c of I, which I've done that earlier, and z minus z of naught bracket of j, we call it star. Now, where f of x equals to 1 all over 2 pi I integral of f of x all over x minus z this x. Now, and c of I will be equals to 1 all over 2 pi of I integral of f of x divided by x minus z naught bracket of z plus 1 dx. Now differentiating s down by representing the equation this, it means my f of z equals to summation of it run from to j is 0, I c of j of z minus z of naught j minus 1. F prime prime, which is as far we are working towards series, we must differentiate it to be j equals to 0 of this, of j bracket of j minus 1, z of I, j, and z minus z naught bracket of j minus 1. Now, okay, now we can now run to nth term of this. If we are to run to nth term, okay, when I'm talking about the nth term, it means my nth term f of z into bracket of now summation of j equals to n of infinity. It will be j equals to n to infinity. It will be equals to now we'll be talking about j minus 1 and j minus 1, j minus 2, run it to it should not be j minus n plus 1 bracket of and bracket of cj bracket of c, sorry, I have to continue, bracket of cj and bracket of zj, okay, bracket of zj. Now it will be z minus z naught bracket, z minus z naught bracket, okay, because when it's c minus z naught bracket of, yes, that is c minus c naught bracket. Now, okay, now bracket, please take note of that. Now it means if I'm having my f of nz, it will be equals to, what am I having here? Yes, and n factorial c, which is equals to n factorial divided by 2 pi I integral run from, because we are running of integral f of z, f of x all over z minus z naught bracket of j plus 1 dx. Now dx. Now with help of Cauchy integral, Cauchy-Riemann integral formula. Now with help of that, it means my z of z is 0 now of I of j z minus z naught bracket of j. That is where my zi equals to 1 over 2 pi I integral of contour over f of z divided by x minus z bracket of okay, j plus 1 dz, j plus 1 dz. Now it means my r of 1 less than of z less than r2. less than R2. Now let's now move on to, let me quickly establish Lorentz series, which is with help of Lorentz series. With help of Lorentz series, I can say that with Lorentz series, Lorentz series will be equals to f of c equals to summation of to 0 to this of j z of naught of j plus summation of g of 1 of this of, let me just pick of j z of z naught bracket of j. Now, which is my f of z will be equals to 8.9. Normally 1 2 divided by z of minus z naught of n plus z of minus n minus 1 divided by z of naught over n minus 1 plus 8 minus n minus 2 divided by z of plus, run it to 1 to be a of minus 1 divided by z minus z naught plus and so on and so forth, which is Lorentz series. With Lorentz series, I can answer that what? Plus a naught plus a1 bracket of z minus z naught plus a2 bracket of z1 naught bracket of 2 plus and so on and so on. Now, Taylor series consider of two parts. Consider of two parts, which are principal part and analytic part. Now it means my f of z equals to summation of j equals to 0 of this a of j bracket of c minus z naught bracket of j plus summation of j equals to 1 to infinity. It means b of j divided on z minus z naught bracket of n minus 2. Okay, now without going far, it means here is called analytic part, and this one is called principal part. Analytic part and principal part. Okay. Now, how I wish I can show one example. Okay, it means I have to show another example. I have to show verification of this analytic part and that part on our preview on our next video. It means I need to stop here. Okay, please take a look at this is analytic part, this is the principal part. Okay, once again, don't forget that you are watching further solutions academy. Encourage us more, help us to share our video and subscribe onto it. And if you want to make any contribution by helping us in finance, in money, you can WhatsApp us 2348034495990. 0. You can contact us, call us, or you want to do on WhatsApp. You can WhatsApp us also. At this point, we need your help to buy a bigger board and a better camera, and to buy many things, marker, and so on and so forth. Thank you for watching. Thanks for watching.